Hello and welcome to 1995. In this year, a great statue was constructed in the British Library courtyard. Who was the sculptor?
Polizzi.
Polizzi.
Paolozzi.
Paolozzi Newton. It's on an original by Blake and shows the mechanization of human thinking. How we become encast in technical way of knowing things, the start of the left hemisphere dominance, where everything should be measured, cut apart, weighed, and how we distance ourselves from everything real, making it to an abstraction. It's actually a very close connection to what we're reading now, how mathematics become mechanized, and we read earlier how Gödel despised the idea of a mechanized mathematics, that it should be a human being there. Also strengthened by Sir Roger Penrose. Humans are quantum mechanical, not arithmetical or anything similar. So every idea to turn us into Newtonian mechanistic devices would lead to disaster. So I like the statue. It is reality today, and one of the points with this lecture series is to counteract a lot of the problems that erupts when you go too far into the mechanization and cutting up, distancing yourself. The further you get from what you try to investigate, the more forehand, that less knowledge you gain. And we get into these empty concepts that plagues us today. Our call is for the invigoration of thinking once more. Invigoration. Make it healthy. Make it.
Invigorous, make it great again.
Remorse. Last time we looked into the very difficult thing. Well, sort of, it seems that he's criticizing Hofstadter when he admires him at the same time. We need to know that there is no general take on anything in Wittgenstein. But the point is still there, and it is that the incompleteness or the loop really isn't there because there is no action that either points to one or the other way. We need physics, we need counting, we need doing the things. Only then can they get a reality. And that goes for proof, proposition, true, incomplete, number, and mathematics. And they are a result of in the tangle of games created with numbers and plus and minus signs, etc. With incompleteness, this warrant is lacking. It doesn't have its feet firmly on the ground, together with reality, which is doing. Could compare with the two spirals I showed earlier for the diademata and the Stephanos. and how they gather together in Stefanomen or something. The doing of the both contradictory spirals is the action. Only with contradiction can we have action. And also, action is contradictory in itself. We spoke about that, and I think I mentioned that in David McNeill. The instability inherent between gesture and language is what leads to newness, a thrust forward, going forward, having meaning. There is no static meaning, which is this in great contrast to the Blake depiction, latest statue by Paolozzi. Even Newton himself is a mechanic here. We seem to think today that we are made up of parts and that they work independently. No, we are one whole thing without parts. Wholeness comes before the different things, the atomistic constituents. Global relations before local relations. I will continue on page 9. I left off, so we will start the third paragraph. In the recent book, Gödel's Way. Three eminent scientists discuss issues such as undecidability, incompleteness, randomness, computability, and paraconsistency. Paraconsistency. I approach these issues from the Wittgensteinian viewpoint that there are two basic issues which have completely different solutions. Completely. There are the scientific or empirical issues, which are facts about the world that need to be investigated observationally, and philosophical issues as to how language can be used intelligibly, which includes certain questions in mathematics and logic, which need to be decided by looking at how we actually use words in particular contexts. In particular contexts. When we get clear about which language game we are playing, these topics are seen to be ordinary scientific and mathematical questions like any others. Wittgenstein's insights have seldom been equaled and never surpassed, and are as pertinent today as they were 80 years ago when he dictated the blue and brown books. Blue and brown books. In spite of its failings, really a series of notes rather than a finished book. This is a unique source of the work of these three famous scholars who have been working at the bleeding edges of physics, math, and philosophy for over half a century.
Bleeding.
Da Costa and Doria are cited by Wolpert since they wrote on universal computation, and among his many accomplishments, Da Costa is a pioneer in paraconsistency.
Alliteration. Pioneer in paraconsistency. Da Costa.
Pioneer in paraconsistencies. Chaitin's proof of the algorithmic randomness of math and the omega number are some of the most famous mathematical results in the last 50 years. And he has documented them in many books and articles.
Hooray.
His co-authors from Brazil are less well known, in spite of the many important contributions.
With the butterfly.
The butterfly. For all the topics here, the best way to get free articles in the search. Chaitin is an American, and his many books and articles are well known and easy to find. But Da Costa and Doria are Brazilians, and most of Da Costa's work is only in Portuguese.
Portuguese is needed.
But Doria has many items in English. The best collections of the work are in Chaos, Computers, Games, and Time. I think we skip a bit here. We could go to page 11 and the penultimate paragraph there. Doria and Da Costa also proved 1991 that chaos theory is undecidable.
Undecidable.
Undecidable. Undecidable. When properly automatized within classical set theory, is incomplete in Gödel's sense. Gödel. The articles, and especially the group discussion with Chaitin, Fredkin, Wolfram.
Wolf, oh no.
Randomness through computation is a stimulating continuation of many of the topics here, but again lacking awareness of the philosophical issues and so often missing the point. Chaitin also contributes to causality, meaningful complexity, and embodied cognition. Replete with articles having the usual mixture of scientific insight and philosophical incoherence. And as usual, Nobody is aware that Wittgenstein provided deep and unsurpassed insights into the issues over half a century ago, included embodied cognition.
Embodied cognition.
Embodied cognition. Need to jump here. Page 14. I'm sorry about this getting a bit chatty here. The third paragraph here. As Rodich, Berto, and Priest, another pioneer in paraconsistency, have noted, Wittgenstein was the first by several decades to insist on the unavoidability and utility of inconsistency. We now see that the disparaging comments about Wittgenstein's remark on math made by Gödel, Chaitin, Dummett, and many others were misconceived.
Damit, you were dumb.
As usual, it is a very bad idea to bet against Wittgenstein. Some may feel we have strayed off the path here. After all, in Gödel's way, we only want to understand science and mathematics, and why these paradoxes and inconsistencies arise, and how to dispose of them. But I claim that is exactly what I have done by pointing to the work of Wittgenstein.
Yummy, yummy.
Our symbolic systems have a clear use in the narrow confines of everyday life.
Everyday life.
Everyday life. Everyday life. In what we can loosely call the mesoscopic realm. Dadaism, the space and time of normal events we can observe unaided and with certainty. And with certainty.
Med the day of the week, mesoscopic.
Mesoscopic. Mesoscopic.
Mesoscopic.
But we leave coherence behind when we enter the realms of particle physics or the cosmos, relativity, math beyond simple addition and subtraction, with whole numbers and language used out of the immediate context of everyday events. The words or whole sentences may be the same, but the meaning is lost
Lost.
Are changed or, no, let's see here. It looks to me like the best way to understand philosophy may be to enter it via Berto, Rodich, and Floyd's work on Wittgenstein, so as to understand the subtleties of language as it is used in math and thereafter metaphysical issues of all kinds may be dissolved.
Dissolved.
As Floyd notes, in a sense, Wittgenstein is literalizing Turing's model.
Model.
Bringing it back down the everyday and drawing out the anthropomorphic command aspect of Turing's metaphors.
Anthropomorphic command.
Anthropomorphic command.
Of the metaphors.
As Wittgenstein noted, most of what people, including many philosophers and most scientists, have to say when philosophizing is not philosophy, but it's raw material.
Raw.
Chaitin et al., well, as even Wheeler, in repeating the mistakes of the Greeks with elegant philosophical jargon mixed with science.
Elegant philosophical jargon mixed with science.
I suggest quick antidotes via my reviews and some Rupert Reed, such as his book A Wittgensteinian Way with Paradoxes.
Antidotes. Pharmacon. Yummy, yummy.
Indeed, indeed, here we go. Or go to Academica Edu and get his articles, especially Kripke's conjuring trick and against time slices.
Slices.
Oh, slices of time. Why not? Let's have a slice of time, I think. And then as much of Searle as feasible. But at least his most recent, such as Philosophy in a New Century and loads others. There are also over 100 YouTube on Searle, which confirm his reputation as the best stand-up philosopher since Wittgenstein. A major overlap that now exists and is expanding rapidly between game theorists, physicists, economists, mathematicians, philosophers, decision theorists, and others, all of whom have been publishing for decades closely related proofs of undecidability. Undecidability.
Undecidability.
Impossibility.
Oh no.
Uncomputability. And incompleteness.
Incompleteness. Incompleteness. Yummy, yummy, yummy.
One of the more bizarre is the recent proof by Armando Assis that in the relative state formulation of quantum mechanics,
Armando Assis, Armando Assis.
formulation of quantum mechanics, one can set up a zero-sum game between the universe and the observer using the Nash equilibrium.
Nash equilibrium, yummy,
Of
yummy.
course, from which follow the Born rule and the collapse of the wave function
Collapse.
of the wave function.
Let me collapse. Almost.
Gödel was first to demonstrate an impossibility result, and it is the most far-reaching, but there have been an avalanche of others. Avalanche. As noted, one of the earliest in decision theory was the famous general impossibility theorem discovered by Kenneth Arrow Fletcher in 1951. It states roughly that no reasonable, consistent, and fair voting system can give sensible aggregating individuals' preferences into group preferences.
Group preferences.
Can give sensible results. The group is either dominated by one person, and so Git is often called the dictator theorem.
Dictator theorem.
And there are intransitive preferences. Arrow's original paper was titled A Difficulty in the Concept of Social Welfare and can be stated like this: it is impossible to formulate a social preference ordering that satisfy all of the following conditions: non-dictatorship,
I want to be a dictator.
individual sovereignty, unanimity, freedom from irrelevant alternatives, and uniqueness of group rank.
Group rank.
Group rank. We will go to page 17 and the third paragraph.
17.
Wittgenstein's prescient grasp of these issues, hey!
Grasp.
Including his embrace of strict finitism and paraconsistency, is finally spreading through math, logic, and computer science. Bremer has recently suggested the necessity of a paraconsistent Löwen's-Kollen theory. Any mathematical theory presented in first-order logic has a finite paraconsistent model.
A finite paraconsistent
model. Very good. Bertie continues, of course, strict finitism and insistence on the decidability of any meaningful mathematical question go hand in hand. As Rodich has remarked, the intermediate Wittgenstein's view is dominated by his finitism and his view of mathematical meaningfulness as algorithmic decidability, according to which only finite logical sums and products are meaningful because they are algorithmically decidable. The intermediate Wittgenstein, how different indeed. In modern terms, this means they have public conditions of satisfaction. That is, can be stated as a proposition that is true or false. And this brings us to Wittgenstein's view that ultimately everything in math and logic rests on our innate ability to recognize a valid proof. A valid proof.
Ability to recognize a valid proof.
A valid proof.
Our innate ability to recognize a valid proof.
Bertogan, Wittgenstein believed that the naive notion of proof had to be decidable, for lack of decidability meant to him simply lack of mathematical meaning. That is, Wittgenstein believed that everything had to be decidable in mathematics. Of course, one can speak against the decidability of the naive notion of truth on the basis of Gödel's results themselves. But one may argue that in the context, this would beg the question against para-consistentists. Wow, I made that. And against Wittgenstein too. Both Wittgenstein and the para-consistentists on one side and followers of the standard view on the other agree on the following thesis: the decidability of the notion of proof is and its inconsistency are incompatible. Incompatible.
Kom, bom, 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 bom.
Bom, bom, bom.
Incompatible.
Incompatible.
Incompatible. Incompatible.
Compatible. Incompatible. But to infer from this that the naive notion of proof is not decidable invokes the indispensability of consistency, which is exactly what Wittgenstein and the paraconsistent argument call into question.
In question. My notion of proof is not desirable. It was the indispensability of consistency.
For as Victor Rodich has forcefully argued, the consistency of the relevant system is precisely what is called into question by Wittgenstein's reasoning. And so, therefore, the inconsistent arithmetic avoids Gödel's first incompleteness theorem. It also avoids the second theorem in the sense that its non-triviality can be established within the theory.
Hallelujah, hallelujah, hallelujah. Its non-triviality can be established in the theory. Hallelujah, hallelujah.
And Tarski's theorem too, including its own predicate, is not a problem for an inconsistent theory, as Gray and Priest noted over 20 years ago.
Priest, hallelujah, hallelujah, hallelujah.
This, again, brings to mind Wittgenstein's famous comment. Da, 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 da.
Yummy.
What we are tempted to say in such a case, of course, is of course not philosophy, but it is its raw material.
Blech.
It is its raw material.
Raw.
Thus, for example, what a mathematician is inclined to say about the objectivity and reality of mathematical facts is not a philosophy of mathematics, but something for philosophical treatment.
Philosophical treatment.
And again, decidability comes down to the ability to recognize a valid proof, which rests on our innate axiomatic psychology, which math and logic have in common with language.
Hallelujah, hallelujah.
And this is not just a remote historical issue, but is totally current. I have read much of Chaitin and never seen a hint that he has considered these matters. These matters.
A hint, a hint.
Not even a hint. Again, the work of Hofstadter also comes to mind. His G.E. Beer won a Pulitzer Prize and a National Book Award for science.
Hallelujah.
Sold millions of copies and continues to get good reviews. But he has no clue about the real issues.
Ouch, ouch.
And repeats the classical philosophical mistakes on nearly every page.
Ouch, ouch, ouch.
His subsequent philosophical writings have not improved. He has chosen Dennett as his muse.
Ouch, 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 ouch.
But as these views are vacuous and unconnected to real life, he continues to do excellent science, on the other hand.
Hallelujah, hallelujah, hallelujah.
Hallelujah, indeed.
Dennett, das ist Muse. Muse. Maus. Dennett ist eine Maus.
Muse or a mouse, yes. Page 20, paragraph number 2 there. Likewise, on page 54, that sequel, it was Wittgenstein Mouse or Rat who has given us the first and best rationale for para-consistency, long before anyone actually worked out a para-consistent logic.
Hallelujah, hallelujah.
Again, as Wittgenstein pointed out many times, it is critical to be aware that not everything is a problem, question, answer, proof, or a solution in the same sense. And accepting something as one or the other commits one to an often confused point of view.
Ouch, ouch, my dear. Ouch, 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 ouch.
In the discussion of physics on page 189, we must remind ourselves that point, energy, space, time, infinite, beginning, end, particle, wave, quantum, are all typical language games that seduce us into incoherent views of how things are by applying meanings from one game to a quite different one. I have read many recent discussions of the limits of computation and the universe as computer, hoping to find some comments on the amazing work of polymath, physicist and decision theorist David Wolpert, but have not found a single citation, so I also present this very brief summary. Summary.
Wolpert.
Wolpert proved some stunning impossibility or incompleteness theorems on the limits to inference that are so general they are independent of the device during the computation, and even independent of the laws of physics, so they apply across computers, physics, and human behavior. Human behavior. They make use of Cantor's diagonalization, the liar paradox, and word lines to provide what may be the ultimate theorem in Turing machine theory, and seemingly provide insights into impossibility. Incompleteness, the limits of computation, and the universe as computer in all possible universes and all beings or mechanisms, generating, among other things, a non-quantum mechanical uncertainty principle and a proof of monotheism. There are obvious connections to the classical work of Chaitin, Solomonov, Kolgomarov, and Wittgenstein, and to the notion that no program and thus no device can generate a sequence with greater complexity than it possesses itself. One might say this body of work implies atheism, since there cannot be any entity more complex than the physical universe. And from the Wittgensteinian viewpoint, more complex is meaningless, has no condition of satisfaction, that is truth maker or test. Even a God cannot determine whether a given number is random, nor find a certain way to show that the given formula, theorem, or sentence or device is part of a particular system. I have read many recent discussions of the limits of computation and the universe as a computer. Hoping to find some comments on the amazing work of polymath and physicist decision theorist David Wolpert.
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 Wolpert. We can go to page 27. Third paragraph. Volpert says it shows that the universe cannot contain an inference device that can process information as fast as it can. That's interesting, quite. And since he shows you cannot have a perfect memory nor perfect control, its past, present, and future state can never be perfectly or completely depicted. Its past, present, or future state can never be perfectly or completely depicted, characterized, known, or copied. So, not a computational universe. Poor Laplace. He was wrong. He also proved that no combination of computers with error-correcting codes can overcome these limitations. Volpert also notes that the critical importance of the observer, the liar, and this connects us to familiar conundrums of physics, math, and language that concern Januszewski. Again, Floyd on Wittgenstein. He is articulating, in other words, a generalized form of diagonalization. The argument is thus generally applicable not only to decimal expansions, but to any purported listing or rule-governed expression of them. It does not rely on any particular notational device or preferred spatial arrangements of signs. In that sense, Wittgenstein's argument appeals to no picture and is not essentially diagrammatical or representational, though it may be diagrammed, and insofar as it is a logical argument, its logic may be represented formally. Like Turing's arguments, it is free of a direct tie to any particular formalism. Unlike Turing's arguments, it explicitly invokes the notion of a language game and applies to, and in the end presupposes, an everyday conception of notions of rules and the human who follow them. Every line in the diagonal representation above is conceived as an instruction or a command, analogous to the order given to a human being. And there we end with a positive note of human being.
Human being. Okay, human being. Human being.
Human being, not a human doing. 27. So let me try here. I'm just going to get a very brief overview because there was a lot in one time. The most important takeaway when it comes to math is the diagonalization. Diagonalization. Diagonalization is very important to read off large number series, and you do that diagonally, and you enforce a geometric helper, which is spatial. But still, Rodich, and Priest and et al. Has proved not even that can be decidable. So there is no way of reading off, not even the universe can be read off. It will be undecidable. So there is quite a strong blow against Laplace. The Laplacian view was a discussion he had with Napoleon, supposed discussion, but it's very apt to mention it anyway. He said, when he corrected some of the planetary circles that Newton wasn't able to fix, he managed to fix them and make do for them, and people were very impressed. And in the end, it turned out the calculative force, this is why this is important, this is a sort of calculative force, was enough to predict the movements of the planets. And Napoleon got shocked and asked, where is God then? Because one of the reasons God still existed, and this was in 1799, was that he had to take care of the planets. It's actually something that Newton said. And he said, I have no use for that equation. So the computability makes for determination in the universe and in ourselves as well. And this nicely parallels with what we learned as late as, I think, yesterday from Sir Roger Penrose. Mind is not computable, not in the normal sense anyway. And this, I need to emphasize that there's no one who thinks this. The author of this, Starks, is absolutely right. Very few people in the whole world that reasons that way. Roger Penrose is one. Wittgenstein was ahead of his time, long before Sir Roger Penrose et al. But it was inherent in quantum mechanics, although not expressed to that way. And this is also the point of so-called criticism of Douglas Hofstadter. Not really criticism, but it has to do with Hofstadter and everyone else on this planet thinks it's enough for a sort of consistency without any reality, without anything done. Almost like this, because nothing is done here. David Wolpert was one of those who completed the theorem of incompleteness. Sorry about the joke. And is now shown that it won't be possible ever. So William Blake, who we started the whole thing with the statue of Paolozzi, whatever his name was, is now definitely covered, more than covered. I will just read one, I'm going to get comments. This again brings to mind Wittgenstein's famous comment. What we are tempted to say in such a case is, of course, not philosophy, but it's raw material. Thus, for example, what the mathematician is inclined to say about the objectivity and reality of mathematical facts is not a philosophy of mathematics, but something for philosophical treatment. And therein lies the point. We need reality, we need action, we need the spiral to adhere to the other words. We still need gestures. Those things will never disappear. Proof, problem, question, answer, and solution are well founded in everyday language. Put to a higher level, they get another meaning from a new language game. Not to be confused, but still very usable to a certain extent, but not down on earth. Well, thank you very much. So we go to page 17. And it's the third paragraph, and we go down about 10 lines, something like that. As Rodic
has remarked.
As Rodic has remarked, the intermediate Wittgenstein's view is dominated by his finitism and his view. Do note it's the intermediate Wittgenstein of mathematical meaningfulness as algorithmic decidability, according to which only finite logical sums and products are meaningful because they are algorithmically decidable. And if you go down, and this brings us to Wittgenstein's view that ultimately everything in math and logic rests on our innate ability to recognize a valid proof. So it's dependent on us in the end, not on a mechanical thing. We know what is a proof, a question, an and, a start, a proposition. We know that it doesn't rest on something else. Only we know that. And as you can hear, that goes against the grain of what people are thinking, that there is an ulterior algorithmical thing, or we can be reduced to AI or something. No, we cannot, but we still know if something is a valid proof. We cannot show how it's done, so to speak, but we still know it. We happen to share it most often, but that still doesn't mean that it's outside ourselves. And that, I would say, is the most important point I heard in a long time. And once again, it equals very nicely with Sir Roger Penrose's. I think it's time for Kalle to cut in.
Thank you.
You are most welcome.
We go to page 40. So, Starks gives recommendations, and it's great to have recommendations. The third line from down, from page, you see, Roberto, product uploads for Wittgenstein.
Oh, yeah.
So we need to.
The third paragraph and the first line there, okay.
Now, this is the third line from down.
From the bottom, okay.
From the
yeah.
bottom. So the recommendations, and we could follow them. Try to discuss them in future episodes. Better Luca Floyd.
Yes, and read as well.
Yes, I was going there on page. This is the second page, I think. That is antidote Robert Reed. He mentioned that,
yeah.
Absolutely. So we have to go through him also, and perhaps I don't know Armadasis. Perhaps I don't know. Any other recommendations by? So we have these 4 or 5 scholars that we will take up. Hopefully.
Very good. I already got some paperwork from Rodic and Bertov.
Great. And now, except for besides these recommendations, let's go, for instance, to page 36 or something like that.
26, sure.
Let me see. Was it 36? No, it was. But, okay, it doesn't matter too much. I jumped to 27.
Yeah, sure. Wolpert and all that, yeah, plus
Yes.
down the drain.
So on page 27 the post is about Wolbert. Okay, so Wolbert, he proved that okay, so Wolbert also knows the critical importance of the observer, the liar.
Oh yeah.
That is, so in the paradox of the liar, you have the Cretan who says that all Cretans are liars.
Yes.
And this paradox has actually been very helpfully analyzed by Wittgenstein.
Yeah.
And he says that you have to take in the context.
Yeah.
So of course it's not we shouldn't read as a statement in isolation.
No.
Of course you have the observer, the Cretan.
The Cretan, exactly. The
So-
Cretan is there. It's a person.
The observer.
Probably have a name as well. Georgius or something like that.
And this observer we could also compare to the decider, because Wittgenstein said everything must be decided. So it depends if it's the Cretan who must do the decision or we. It's perhaps both and.
But it's an excellent point you made there. The Cretan is a person, and the Greeks ignored that. He was just nobody. He was a person in general, a universal. No features, no beard, not even arms, nothing. Disembodied somehow. No, he's a person, and the paradox disappears, because if you meet the Cretan and you know him, maybe even, it wouldn't be a problem. So you see the criterion, the doings, the actual reality do count, and it will never cease to count and have an effect. It will always be effectful.
So let me say this was on page 20. The last 10 lines on page 20. Page 20, the last 10 lines. One might say this body of work implies atheism, since there cannot be any entity more complex than the physical universe. And from the Wittgensteinian viewpoint, more complex is meaningless, has no condition of satisfaction, that is truth maker or test. Even a God, and that is a device with limitless time and space and energy, can determine whether a given number is random. Nor find a certain way to show that a given formula, theory, synthesis or device is part of a particular system. That is, we can compare this with the liar paradox, and that could be a truth maker. The truth maker there is actually the creator himself.
Yeah.
He's actually in the system. He's both inside and outside. I think that's very important, that you need an observer which is both inside the system and outside the system. So it's contaminated, and that I say is truth maker.
Yeah.
And therefore God actually is possible. I don't know what Wolbert actually means, but I think that he wants to exclude God, because he says that he is, so to say, outside of the system. I don't know. Or how do you understand Wolbert? But anyhow, I think
he makes possibly. Stark doesn't make a point of telling what his actual point is. Let's try this double point. I would say double point.
But anyhow, we can compare God with the Cretan himself.
Yeah.
That is, he's already part and outside of the system. Therefore, you cannot really compute him. Or the God himself, he is, what would we call it? He decides in the Wittgenstein system. He's the decider and observer, both inside and outside of the system. And therefore, you cannot compute him.
No. And I can also, the Wittgensteinian view, we don't know that from this context, could be that Wittgenstein is an actual God.
Excuse me?
That God is an actual God, so to speak. That he is actually here. in the sense that he does exist or do things. And that puts him in the same position as the Cretan.
Mm-hmm.
So he's not a computational system somewhere transcendentally like the. I think most people today believe in sort of Tigmarchian God. Because with this default, we don't see any God, we don't see any doings of God. We are Laplacians, to be honest. So we turn God into some sort of a transcendental thing. And then it has to be, like suggested here, he has to be some sort of computational God. Actually was the God of Newton.
And I think the answer is actually in the coastlines, in the borderlines.
Oh yeah.
Like in the fractal theory. So what is the coast? It's both sea and the land. And therefore you cannot calculate it.
No.
Because the coast and the sea changes itself all the time.
They're both fractal. They're both fractal as well. Exactly. Very good point, yeah.
And that is also, we could compare actually, and resolve the Cretan paradox by comparing with the coastline, because the Cretan is both at the land, at the sea at the same time, and is contaminated, so to say, of both systems, inside, outside.
Yeah, yeah. And that's how it is, yeah. Definitely, very good.
Let's end there.
Yeah, sure. Thank you very much, Kalle Lundahl. Thank you everyone for checking in. Have a very nice morning, afternoon, day, or night, wherever you are. Bye-bye for now.